I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will see an example problem for Minimax algorithm. Before going into the problem, let us discuss what is Minimax algorithm. This Minimax algorithm is a decision-making algorithm used in game theory and artificial intelligence to minimize the maximum potential loss or maximize the minimum potential gain. It works by considering all possible moves and their outcomes, then evaluating the best moves by assuming the opponent will make the best possible counter move. The algorithm recursively explores the game tree, assigning a score to each node based on the potential win or lose, and finally selects the move that maximizes the minimum score, hence the name Mini Max. We'll see one by one. The first we'll see what is Minimax algorithm? So the Minimax algorithm is a recursive algorithm or backtracking algorithm widely used in decision making and game theory. It systematically evaluates possible moves and determines the optimal decision for a player, assuming that the opponent also plays optimally. This ensures that every move made is strategically sound. This algorithm is commonly applied in two-player games such as chess, checkers, tic-tac-toe, Go, and other two-player games. It helps AI-driven system compute the best possible moves considering all potential game outcomes. By doing so, it enhances the decision-making capability of AI in competitive environments. The Minimax algorithm works by computing the mini-max decision for the current states of the game. It examines various possibilities and selects the move that provides the most favorable outcome for the player using the algorithm. The opponent's responses are also taken into account to ensure an optimal strategy. Next, how the min-max algorithm works. In the min-max algorithm, two players compete against each other. Max and min. Capital MAX means max and MIN min. The max player attempts to maximize the game score by choosing the moves that lead to the highest possible value, while the min player does the opposite, trying to minimize the score. This back and forth strategy ensures that each move considers the opponent's best possible response. The algorithm explores the entire game tree using depth first search DFS approach. It analyzes each possible move and determines the optimal choice by examining all possible future states of the game. This exhaustive search allows the AI to anticipate various gameplay scenarios. The Minimax algorithm proceeds by reaching terminal nodes of the game tree where the final scores are evaluated. It then backtracks. What will it do? It then backtracks, propagating these values of the tree to determine the best moves at each stage. Max always selects the highest value while min selects the lowest, ensuring that the AI makes the most strategic decisions throughout the game. So this is the example problem. See here, this triangle represents the max and opposite to the triangle, no, we are calling it as min. This symbol always we are calling it as the max, and this symbol we are calling it as min. Sometimes in the examination they'll give values also, or directly they'll mention it as max or min. Most of the cases will be given with these type of symbols. It represents the max, this symbol represents the min. So this is the example problem. The game tree consists of multiple layers representing different decision paths in the game. At the top is the maximizing player. Here, top, it is the maximizing the player. So this is the maximizing the consists of multiple layer representing the decision parts in the game. At the top, it is the maximizing player. We are calling it as the max, whose objective is to choose the move that results in the highest possible score. Max evaluates all possible outcomes and picks the best option available. The minimizing player, min, this is the min, works in opposite to max. Min's goal is to select moves that minimize the max score, making it more difficult for max to achieve an optimal outcome. This min plays strategically to reduce the advantage of the maximizing player. The game tree is structured hierarchically with alternating max and min nodes. At the bottom of the tree these nodes are leaf nodes representing possible game outcomes with assigned scores. These scores helps to determine the best course of action as the trees travels upward. Leap node. So if you are considering this in leap node evaluation, these 3, 5, 2, 9, 0, 7, 8, 6. So how we are going to evaluating is the leap nodes contain the final scores based on the possible outcomes of the game. These values represents the results of different possible moves played by both players throughout the game. In the min-max algorithm, win is generally assigned. In this algorithm, win is generally assigned a positive score. Example, we can call it as +5, +9, etc., indicating a favorable outcome for max. A loss is assigned to a lower or negative score. We can call it as 0, -1, etc., representing an undesirable result of max. A draw is neutral, often gives a score of 0, as it does not benefit either player significantly. For the specific tree, the leaf nodes contain the values are. What are all the leaf node values are here? 3, 5, 2, 9, 0, 7, 8, and 6. These values will be used to determine the best possible moves as we move up the tree. Maximum player turn. This I have told you. At this step, its maximum turn is to decide. Maximum must select the maximum value for each pair of the children nodes. So max, what it will do is makes decisions at the lower level of the tree first, ensuring that best possible moves is chosen at each stage. For the leftmost max in this case, max compass this 3 and 5. This I'll tell you. Selecting the here. This is the max value. So it will select what? 3 and 5. Comparing these two values, which is the maximum value? 5. So here we are writing it as 5. Selecting 5, it is the highest. For the next max node, max compass 2 and this 2 and 9. What is the value will be selected? So we are selecting 9 as the highest. For the bottom left max node, max compass 0 and 7. Here selecting 7 as it is the highest. Next, for the bottom max node, the max compass 8 and 6. Selecting 8 as the here, 8 as the highest. So the updated game tree now has intermediate values of, what are all the intermediate values? 5, 9, 7 and 8. These values will be used for the next step when min makes its decision. Next, see here, min player turn. So in this case, in the min player turn, I'll write it in different color. in the min player turn, what will happen? Now it is the min turn. Here max it has selected. Min's turn to make decision, and min must select the minimum value from its available option. Min tree minimizes the maximum advantage, max advantage by choosing the least favorable score for max. For the left, in this case, for the left min node, min must choose between here 5 and 9. What is the value will be selected? Since min aims to minimize the value, it selects 5. It is here. We have to write. It selects 5. For the right min node, min must choose between 7 and 8. To minimize the score, it selects 7. That is the minimum value. At this point, the updated values in the game tree are 5 and 7, which will be used in the final decision making step by max. So final, this I have written it in this slide. Okay, final decision. So what is the final decision? 5 and 7 has been selected in the second layer. Now the max player at the root must make a final decision. Since max always selects the highest possible value, it must choose 5 and 7. Comparing both values, max selects what? 7. Why? Because 7 will be selected because it is the highest among the available choices. Among 5 and 7, 7 is the highest. This means that the optimal strategy for max is to follow the path that leads 7, ensuring the best possible outcome given the min also plays optimally. So the final decision results in max choosing is 7, which determines the best move in this game scenario. So the final value is the 7. So coming into the conclusion, I hope everyone understood these steps. Coming into the conclusion, the min-max algorithm ensures that the maximizing player selects the best possible move by carefully evaluating all possible options in the game tree. So in this case, by considering the opponent moves, max can anticipate possible threats and counter them effectively. The algorithm is crucial tool in two-player decision-making games such as chess, checkers, tic-tac-toe, etc. It systematically explores the entire game tree to find the most optimal move while accounting for the opponent best. By following the min-max strategy, AI can make strategic and well-informed decisions, leading to improved gameplay, performance, and stronger competitive strategies. So for this problem, so this is the problem. These are all the leaf nodes. The second step is we have to find out the leaf node evaluation for this problem. And when we are calling it as the positive scores, namely plus or plus 5 or plus 9, negative scores we are writing as 0 or 1. These are all the examples. For the given problem, these are all the leaf nodes. And the next step is maximum player win. In this case, we have to write these type of steps, these steps to be written in the examination. Next, min player turn. Min player turn. Here, the third step. First, maximum value is being selected. This symbol represents the minimum. Minimum value among these two will be selected. And the next final decisions by the root node is the maximizer. So my root node will be selecting the 7. The max player at the root node will choose the maximum value between two children among that is 5 and 7. So max chooses the 7. So the maximum of 5 is the 7. So in this way we have to calculate the min max value and finally we'll be selecting the maximum value. So in this example, I have taken one example here. So yeah. Here the leaf node values are what? Leaf values. Leaf node values are in this problem 4, 11, 7, 2, 5. This is 6. This value is the 6. 6, again 12, 6 and 2. So this is the max value and represents. So from this, here 4, 11 and 7 are given. Among these three, it has to select the minimum value. What is the minimum? This symbol represents the minimal. Here it has got only one leaf node. So same value you have to keep it. The minimum value is 4. And among these three, 2, 5, 6, what is the minimum value? 2. And 12, 6, 2. What is the minimum value? 2. And this is the root node. The root node select 4, 2, 2. We are selecting in the second layer. Among these three, the maximum value is, this is the max. Max, this represents the min. And final value is 4. So in this way, we have to calculate the final decision value by using the min-max algorithm. Hope everyone understood the simple algorithm. The remaining things we'll discuss in the next lecture. Min-max algorithm. Next we will see the alpha beta pruning algorithm. Thank you.